go. 6-2 continued. And that was percents, decimals, fractions. Yeah. Okay. Percents, decimals, fractions. And whoever you guys take for developmental math 2, you guys are ready. Of anything, I feel you guys are all ready. So you're gonna be good. I just taught developmental math 2, and you go over some things we did in class already, and then you start learning a few new things. You'd be fine. All right, here we go. We are, okay, this is what we didn't get to. Writing fractions. Uh-huh.
Are you teaching developmental math 2 online?
No, not yet. I still have 3 more classes they're giving me. The one I do have is in school. But I'll let you know. They told me I'd get it my rest of my schedule this week. So I'll let you know.
Okay.
But so far,
If
so
you get
far,
it, would
no.
you shoot me an email?
What's that?
I said, if you get developmental math 2, will you shoot me an email and let me know so I can sign up for it?
Yeah, absolutely. Absolutely.
Thank you.
You're welcome. Yeah, I'll shoot. I'll just send you all an email. If I happen to get it online, I'll send all of you an email. I'm hoping, cross fingers. Okay, we're gonna practice, although we didn't even talk about it yet, but this is, I want to do problems and show you how to do them. As I said, explaining it, I just want to show you as we go. So we have 3/25. It's a fraction. We want to make it a percent. We can make a percent if we can get the denominator equal to 100, because it should be your percent. If you get the denominator to be 100, your percent is your numerator. So you can do this for some problems, but not all problems. 25, I can make that 100 easy. I can multiply it by 4. If I, just like every other fraction, whatever you do in the denominator, you want to do the numerator. And I would get 12 over 100. And that top number is your percent. That means it is 12%. So if you can get the denominator to be 100 by multiplying by something, you just multiply the numerator by it, and whatever the numerator becomes, whatever over 100 is your percent. Again, this is not for every problem. So when we get to a problem we can't do it, I'll show you how to do that one. Let's say I tell you a mixed number, 5 1/2. Well, I got to put it as an improper fraction first. So if I rewrite it, improper fractions. 5 times 2 is 10, 11 halves. Now, I want to see if I can get the denominator to be 100. I think with 2 I can, because 2 times 50 is 100, which means I'm going to multiply 11 by 50. It's going to be a percent bigger than 100, which is fine. So we have 100. And then 50 times 11 is 550. So my percent is 550%. Let me make sure that's right. My gut tells me it's right, and then I don't feel like it's right. Yeah, it's 550. Yep. 3. 9 over 20. I can also make that 100 because I can multiply the denominator by 5 to make 100. So if I multiply the denominator by 5, I multiply the numerator by 5, and I will get 45 over 100. That means it is 45%. So let's do one that's not going to give you 100. So 9 over 40. All right, so this is the first one that we can't get 100. 40 times what is 100? You could try to figure out the decimal form to multiply it by, but There's nothing easy. You can't multiply by anything easy to get 100. So what you do is you multiply by 100 over 1. And what you're going to get is you're going to get multiply the top and the numerator and the denominator, 900 over 40. We're going to simplify. So one of your 0 can come out. I have 90 over 4. And then I could simplify it again. Do I want to? Yeah, okay, so we're going to simplify it again. I can divide it by 2. 45 over 2. And then I divide it in half. Although 2 can become, can I do this? Hold on. Times 50. What's 45 times 50? Hold on. 45 times 50. 0, 25, 2. Yeah, good. Oh, no, that's not right. Hold on, that's not right. Don't do that. Now I have a question in my head. So hold on. 2, 4, 0, bring on 5, 2, 4, 1, bring down 0, 22.5%. I'm gonna put a question mark on that one. I don't like that one. 50 times 50, I got 225 over 100. 225 over 100. Oh, it will work. Okay, 45, I think I just my math wrong. Okay, why can't I multiply by 50, right, to make the bottom 100? So 45 times 50 was, wait, I just said earlier, it was 2, 2, 2, 5, 0. Yes. Yeah, good. I'm talking to myself, aren't I? Okay. All of a sudden I thought that didn't work, but it did work. Okay, so the zeros cancel out. I'm left with 225 over 10. We divide by 10, like we did before, the number comes smaller. So I move the decimal place one place to the left, and I get 22.5%. Works perfectly. So you'd have to simplify it first before, yes, you got to simplify it first before you put it in percent. Okay. Let's go to something else. Sorry. All right. How about 3 over 17? Now, what I should have done for the last one is not multiplied by 100 over 1. What I should have done, just divide it. So if you can't get it to be 100, just divide it. And that will give you a percent, but it's going to give you a percent in decimal form. All right, how many 17s are in 30? How many 17s are in 30? 1. That's 17. That's 2. That's 10. That's 13. Bring down to 0. How many 17s are on 130? Let's see. That's 49. 7, 8, 9, 10, 11. 17 times 8. 8 times 7 is 56. 8, 9, 10, 11, 12, 13. Okay, so 8 was too much and 7 is fine. So 7. So 7 was not 7. 17 times, sorry. Yeah, 7 was, that's it. 17 times 7 is 119. Subtract, what do I have left? It's a lot more work when you get the denominator to be 100. Okay, so 1, that's 1. I bring down to 0. I have 110. Okay, so I can't use either of them. It has to be smaller. So what's 17 times 6? 42, 102, perfect. Okay, so that's a decimal, right? I just added a 0, decimal. So it's 6, which is 102. If I subtract that, I get 8. I'm going to add another 0. And we're going to round to hundreds. Okay, 17 and to 8. So let's see, maybe 5. Oh, it's going to be too much. It's going to be 4. All right, what's 17 times 4? 28, 468. And then 12 left over. And then we have to do one more time to make sure to see if we can round this or not. We're going to round to the 100. So bring down this, bring down the 0. Another 0, bring it down, 120. Okay, that means it has to be 7 because here's my 119. So if I round it, it's going to be 17.65%. Because decimals that we did before, decimals can go on forever. This is one of those ones that's going to go on forever. So they're going to have to tug and round it. So look at all that work for one that doesn't have, like, you can't get the denominator, right?
I'm confused why you put the decimal after 17.
Because 17 was the end of our problem. That's our problem. Then once I added the 0 here, but I didn't write, that's my decimal.
Can you explain that a little further, why you moved that? Like she's asking, why, I mean, I get, is it just because you're going from to a percentage? Is that is that what it is?
Yeah, say that again.
I'm sorry, are we talking to me?
Yeah, because you're sort of split up, sort of like on my end, I'm sort of like broken up a little bit. Say it again. Yeah, that's all right.
So when you divided 17 or 3 divided by 17, normally your decimal point would go before the 1. So it'd be 0.176, whatever.
Yes. Yeah. Now I know why. Yeah. Okay. I was ahead of myself. You're right. It should be here, right? Yes. I went ahead of myself. I wasn't even thinking about it. Okay. So yes. Let me get this up. Yeah. I know exactly what you're talking about. I just did it in my head without even realizing it. Okay. It is 17, but it's a decimal form of your fraction. Now you got to put it in percent form. So you have to put, I did the same thing. I'm just so used to doing it one time. Sorry. All right. So that's your decimal form, but to get the percent form, you got to move it 2 places to the right. That's how you get 17.65. Now I know why you're asking about decimal place. I wasn't even thinking about it. So this is your decimal form. It's not the percent form. This is your decimal form. Decimal form. To get the percent form, you have to move it 2 places to the right. Basically, you're multiplying by 100. This is when you multiply by 100. You divide it first and then multiply by 100.
You would move it 2 places because it would be the decimal over 100.
Yep.
And so,
exactly.
Okay, I get it.
Yep. Times 100. Yep. Sorry, I didn't realize I even did that. Just habit. There's also another way to do fractions, which I think I like even better than we have to worry about decimal place. There's lots of ways to do these. Let's look at this one, 5/8. I toured with which way to teach it is because there's so many different ways. Usually I just divide them and then I move my decimal place. That's what I do, but this is another way. Okay, so you can do a proportion, which is our next section. So we haven't even done them yet. So I'll show you what to do. 5/8. So it's like, this is how I think of it as part over whole, which I'm going to show you in the next section anyway, is equal to percent over 100. That's a proportion to work with percents. Part over whole, meaning a fraction, right? 5/8 part over whole is equal to percent over 100. So how do I work that out? That means 100 is always going to be 100. And that means I'm going to put a little X here. That's my
Yeah,
percent.
see, this was how I was taught right here. Percent, yeah, okay.
It's unfortunately, maybe I should talk the section after first because yeah, I do this a lot too, but I'm not going to show you yet because it's the next section. So we're going to do it now. I like this better. Yes, I either divide or I do this. So I love proportions. Proportions, you can do so many problems with proportions. I love proportions. Okay, so now I'm going to write it again so I can show you what to do. And if you remember it, that's fine. If not, this is what you do. You cross multiply. So take one cross. It doesn't matter which one you do first. So I'm going to do 8x. 8 times x is 8x equals, and I multiply across this way. And always an equal to. You can only do this if they're equal to each other. Let's say proportion equals 500. Then we're going to divide by 8. Now, when I finish this answer, it'll be the percent and not the decimal form of the percent. So we have 500 divided by 8. I'm going to divide it. I can divide by, I have to do 2 first. So 250 over 4. I can divide more. Do I want to? I don't think so. Yeah, I can divide more. Okay. So now we're going to divide again, but I think it's all right. 250 divided by 4. I can divide it by 2 again. 125 over 2. Okay, now this is an easy division, right? 125 divided by 2 is just 6. 12. That's 0. Bring down to 5. That's a 2, which is a 4. Subtract 1. Here's my decimal place. See how the decimal place now is coming in the right spot because we did it a different way. Bring down to 0 and then 5. So this answer would be 62.5%. That's how you do it with cross multiplying and proportion. The whole next section is about this, how to do them in proportion. So I think I'm going to leave that, and we're going to work on these in the next sections. The whole section's about it, how to do percent with proportion. Okay, so if it's already something you can multiply to get 100, I so would do this first. I do this first too. If you can multiply to get 100, this is what I would do. Then your percent's right there. We're going to forget about this set problem, and we're going to do the rest of them this way. How's that? I like that. Okay, so we're going to do some application problems, and then we'll go back and we'll do a whole bunch of problems with proportion. I think that should have been first. Maybe next time I teach, I'll do that section first. I should write myself a note. I think proportion should be first before this section. Do before 6.3. Because I should have realized it because my notes, I have proportion on this section. Okay, so application problems, here we go. A family decides to spend no more than 27.5% of its monthly budget on rent. Write 27.5% as a decimal and as a fraction. All right, that's it. So how do you write it as a decimal? Well, you take 27.5, which is going to be opposite of the one we just talked about. You got to put in decimal form, so it has to be moved 2 places to the left. In my decimal form, because you're dividing by 100, basically. 0.275. It's always 2 decimal places. So going from percent, you move 2 decimal places to the left. If you're going from percent to decimal, 2 places to the right. So I'm gonna write that down. Percent to decimal, move decimal 2 places to left. That's how you go from percent to decimal. And the opposite, which we're going to do this next. Yeah, not. No, we're going to do it next. I'm going to write here decimal to percent. So let's say, for example, I have 6.25, right? I'm going to move decimal 2 places to the right. So if I have 6.25, which I'm going to bring down that example, 6.25, I would take my decimal and I'm going to move it 2 places to the left. I don't know why I did that either, to 625%. So percent to decimal, you move 2 places to the left. Decimal to percent, move 2 places to the right, decimal place. You'll get back and forth. All right, so we didn't finish. We have to also write it as a fraction, right? Yes, okay. So it's a fraction. We have a decimal of 0.275. This is like an earlier lesson we did, I think last chapter. How do I write that as a fraction? Well, what place is it in? What's the last place? This is tenths, hundredths, thousandths. So it's really 275 over 1,000. And then we got to simplify it. We could divide definitely by 25. These are all, I could definitely see they're by 25s. Okay, so equals, we'll just choose 75 by 25. Let me think this through. So 4 25s is 100, right? 8 25s is 200. And 3 more to make 75. So it'd be 11. See how I did that? 4 25s are 100. 8 25s is 200. I need 3 more 25s for 75. So I didn't even have to divide it pretty much. All right, 1,000 divided by 25. That's going to be 1,000 by 25. How many 25s are in 1,000? So 100 was 4 25s. So 1,000 has to be 40. 10 more, 10 times as much. So 100, there's 4 25s. 1,000 is just 10 times as much, 40, and that would be my fraction. Of course, you can divide it all. I'm trying to show you a different way to think about it. Okay, let's try this one. Did I number it? Yes, I did. 2. I have 2 more. Providence is budget for waste management increased 1 3/4 times over the budget from last year. What percent of increase is this? So they give you it in a fraction form, but we want to put it, they want a percent form. This one, it is, if I make it an improper fraction first, so 1 3/4 really equal to 7/4. If I multiply it by 25 to make 100 in my denominator, I'm going to multiply it by 25 to make 100 in my numerator, right? Because I can make this 100 nicely. 25 times 7, 175. So the answer would be, now we have over 100, this is my percent, 175%. I like them when you can multiply them by something. Okay, then we have a really weird one, and I hope I can draw this for you because it's almost close to like probability, basically. It's a strange one, but just in case it shows up for your homework, and I want you to see it. Okay, so any questions on those two so far? My drawing up might not be to correct specifications. It might not look like it's supposed to look, but I'm gonna try. I'm moving this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, got it. Okay, so then blue, 84%. Purple, 80%. Yellow, that is 12%. Green, 30%. Red is 19. Pink, 41%. Last one, I can read it. Oh, here it is, black. And that is 10%. That's the picture. And this one I like that I can give you like a little insight into like probability a little bit. It's not really probability, but it's a look into probability. Okay, so this is it. There's 100 students were asked to name their favorite color. Results are in this circle graph. And then I'm gonna ask a couple questions. Let me give you a second to write that all down. Something pretty obvious, but hey, first, you guys all right? Okay, first question. What percent of students prefer green? Okay, well, that's just pretty easy to do. We're just gonna find green. Where's green? Green's over here. Green is 30%. So 30% prefer green. This is the one I want to tell you about. What percent preferred yellow or black? So what do you do when they give you two colors and they say or? This is also when you get to probability, which I don't think you're gonna get to like college algebra, I think. Whenever you get to probability, it's done the same way. Or, the word or means add. So you're gonna add them together. The word or means add. So yellow was 12%, or and black was 10%. So the total who preferred either one is going to be 22%. So or always means add in a problem like this, or add. What color was most preferred? No, I don't think my picture really accurate the size of each piece of the pie, but definitely blue because 84%. Blue at 84%. And the last question, I'm gonna let you do this one. How many students, not how many students, sorry, that's not it. What percent of students, not how many. What percent of students preferred red or purple? So you do that one real quick. I'll bring my picture down in case you don't have the picture up. So red or purple? I'm gonna add another one. Something else I want to add. You see in probability of second. I'm gonna add one more at the end. So red or purple? So red was 19%. 19%. Or means add. Purple was 28%. If you add them together, 19 and 28, 17, 2, 3, 47%. Right. Yeah. Yep. All right, here's my last question. I wasn't even on my paper. But this happens a lot too, okay? What percent of students preferred hold on one second. Orange. What percent of students preferred orange? Is there orange in my chart? I don't see orange anywhere. So that's like almost like a trick question, but the answer is this: 0%. There is none. There is no orange in my graph. So if you ever ask that question and it's not in your graph, it's just 0%. All right, so that was the end of 6.2, but we're really going to tie it into 6.4 because we're going to do proportions in 6.4. So we're going to do more percent. So we'll practice a whole bunch more in this section. Questions before I change the page? All right, 6.4. Okay, solving percent problems using proportions. Like I said, proportions can be used in so many different applications. You really want to get comfortable with proportions. You're going to see them a lot. I use them a lot in developmental math too. A lot of things about proportions. And I was going to write what I wrote before. Basically, this is a way to think about proportions. It's part over the whole equals percent over 100. Just like we said, once you get 100 in denominator, your percent's on top, right? So once you get 100 in your denominator, you know your percent, whatever comes out as a percent. Now, with these problems though, you might not just be asked to find a percent. You might be asked to find the part, or you might be asked to find the whole. So we're going to be asked to do all of them. We're going to practice all different ways. The biggest thing to remember is you only can do this cross multiplying thing, if it's an equal sign. I see a lot of students start multiplying everything across. This is only for proportions that have equal. Okay, so let's just go right to problems. 1. What number is 8% of 120? Is a perfect example of how to do a proportion problem. There is also there's another way you can think of this too, because as soon as I write that, I thought of it. You can also think of it as is over of equals percent over 100. You've probably seen that before too. And that's what made me think of it. I have it is and I have it of right there. I just like to think part over whole. Everything's part over whole, part over whole, part over whole. So if I set up my proportion, I'm going to set up what I know first. I know it's 8%, so it has to be 8 over 100. 100 is always going to be there. That's my percent. That's also a part over whole. Part of the percent over 100%. 8 over 100. It's equal to, if one knows what number is 8% of 120. So 120 is my whole, and they want to know what number is 8% of it. And that's what I know that is over of. So is my x, of is my 120. You use that to help you too. All right, we're going to cross multiply. It doesn't matter which one you do first. So 8 times 120, 120 times 8, 960 I got. 960 equals, I'm going to cross multiply the other way, and I get 100x. To solve for x, what do? I'm going to divide both sides by 100. Now, dividing by 100, we know what to do. We move the decimal place 2 places, right? If I'm dividing, this is what we did before. If you're dividing by two zeros, you got to move the decimal place 2 zeros. So I take 960, the decimal place was here, and I got to move it 2 places to make it 9.6. That's my answer. 9.6 is 8% of 120. Okay, they're sort of all going to be like that. So any questions? I'm just going to give you different things, different parts to ask for. I can ask you for percent, I can ask you for the whole, I can ask you for the part, but the 100 is always going to be 100. %27 of what number is 54? So 27% of what number is 54? So I'm going to set up what I know. I know 27% means 27 over 100, part over whole. 27% of what number is 54? So my 54 is my part, and this time I'm looking for my whole. You can also use this to help you. Of what number? See that word of? You go back to is over of equals percent over 100. Your is 54, and your of is your x. Then we're going to go cross multiplying. 27x is equal to, and we'll cross multiply this way. 5,400. And divide both sides by 27. This one I'm going to have to do 7. Actually, I don't even have to. I'll show it to you anyway. Okay, so 5,400 divided by 27. This one's a nice, easy division. Because how many 27s are in 54? 2. Which means I have all zeros left, which means 200. So my answer is 200. So 54 was 27% of 200. Three. What percent of 40 is 75? Now, be careful. I know the 40 is smaller, right? And the 75 is bigger, but which one's your part and which one's your whole? What percent of 40 is 75? So the of is 40 and the is 75. This is actually going to be over 100. So what percent of 40? 40 is my whole. This is my part. Even though it's bigger, it's still the part. Equals x over 100. Because you could definitely have a percent over 100. 40x is equal to, let's multiply this way, 7,500, divide both sides by 40. Okay, so I can take and divide by 10 and take one of the zeros away. So I really have 750 divided by 4. That's what I have left. So how many 4s are in 7? 1. 3 left over, bring down to 5. How many 4s are in 35? That would be 6 times, 9 times 4 is too much. So it has to be 8 times 4 is 32. 3, bring down to 0. How many 4s are in 30? Well, I always said 32 was 8, so it has to be 7, which is 28. 2 left over. Now here's my decimal place, right? Bring down to 0. And 5. So my answer would be, now we were asking for what percent. So the percent would be 187.5%. And we knew it had to be bigger than 100 because our is and our of were sort of kind of backwards. Okay, questions before I do some more? Anything? I think we did one of each, right? We did a percent. We did that. Yeah, we did one of each. So we solved already for a part, we solved for a whole, and we solved for a percent. So you've seen all of them. Let's do some more. Okay. Let's do 65% of what number is 52? Okay, you set it up. Wait like a minute. Set it up. You don't have to do it yet. Just set it up. I want to see if you set it up right. Okay, if you did that, you did it right. How we do? You good? Yep. I see no, I see shaking heads no, and I'm shaking heads yes. Okay, so let's look at it just in case. So 65%, 65 over 100, that's your percent. Of what number? So of what number is your x? This is over of, or part over whole, whatever way you want to think of it as. So of what number, that's why x is on the bottom, because of is on the bottom, is 52. So is 52, of, we don't know, that's our x. I think of it as part of a whole. It's part 52 out of a whole number. We don't know what it is yet. All right, so we're going to cross multiply. 65x equals, let's multiply 5,200, and we're going to divide both sides by 65. I'm going to go right to dividing because I really can't divide by 10. I can divide by 5, but I'm going to go right into dividing. Okay, so what do we get? Well, how about 65? How's that? I can't divide 65 by 5. I can't divide it in 52. I can divide it in 520. Okay, so how many? 8 times 6 is 48. Okay, let's try this one. I'm not sure. 8 times 5 is 40. 8 times 6 is 48. 49, 50, 51, 50. 50. I just found it. That was just by mistake. How I did that, though, I do this all the time. I think about what can I multiply 6 by to get close to 52. I would have done 9 next, but 52, 8 works. Okay, 8 is 520. I have 0 left, which means it's a 0. And that means my x was 80. That's my whole. And worded a little different. What is a number that is 25% of 116? Hey, try saying that one out before we do it. Angel, you can't even see it. Your cat's right in front of your face. I love it. I love watching the animals. It's great. What is a number that is 25% of 116? Okay, so 25 out of 100 equals, by the way, I always leave my percent, so 25 over 100 on the right. You don't have to. It's just a habit of mine. I always put it on the right. Um, what is, that's is, of 116? Set up that way, you did it right, or you can think of it as part of a whole. I'm looking for the part, and the whole is 116. Okay, cross multiply. I always cross multiply the same way too. You don't have to, but I always do. I don't know why. Ever since I learned these, I've always done it this way. I always do that diagonal first, and then I do the second diagonal second. Okay, 116 times 25. Okay, so we gotta multiply this out. 30, 5, 6, 7, 8, 5. I have my 0. 6 times 2 is 12. 2 times 1 is 1 plus 1 is 3. 2 times 1 is 2. So let's see what I got. 8, 9, 10, 5, 6, 7, 8, 9. I got 2,900. Okay, so 2,900 equals, now we're going to multiply these two, which is 100x. We're going to solve for x by dividing each side by 100. And this one is sort of kind of nice because I could divide by 100. These two zeros are gone, and my number is 29. That was a nice one. So what percent of 40 is percent of 40 is 8. And then once you write it, set it up. Let's see if you set it up right. Set up. 8 or 40. 8 is part of 40. It's the part, or you can think of it as the of is 40 and the is 8 equals x over. Okay, you solve this one. See what you get. You cross multiply. Okay. So anyway, we're done. You can Got that, you did it right. Bless you, Amanda. I just saw it. How we do? Good. No, I still see head shaking, no? Okay, see if you can compare, like, if you didn't get it, what you did wrong, let's see if you can see it.
I just keep setting up the problems wrong.
What did you set up?
I
How did you
put,
set it up?
oh shoot. I think I put, well, I erased it. It was like 40 over 100 and x over 8. Like I totally botched it.
Okay, so just pay attention to the words, like what percent, that's my X. So it had to be X over 100 because percent's always a 1 over 100. And then really look at these words too, of and is. That's the is your part and the of is your whole. So is your part and of is your whole. See if you use the words a little bit more like in context to help you. Once you get it, you'll get it. Okay, so try that. We're gonna try this one. The decimal 15.4 is 5% of what number? Try setting it up first, then I'll show you what it is. See if we have it right, and then you can solve it. Okay, so I have it up if you want to look at it and see if you have the right thing. Yeah, good, 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 good. Okay, continue, see what you get. And when you're done, you can look up and I have the answer up there, see how you did, but don't look till you're done. It's another cat. You guys have a lot of cats. All right. Questions? How'd you do? You could, I didn't show any division. And multiplying, just to remind you, when you have 15.4 and you're multiplying by 100, that means you're making it bigger by 2 by moving the decimal place twice. So it'd be 1, 2, which makes it 1540. We did that in like another section too. And divide by 5. I didn't show the division, but it's 308. Questions? I'm going to do one more. And then we're going to go to the last section. Hi, one more to find a percent. I have 2 to choose from. Which one do I want? I don't know. I think we'll do this one. 414 is what percent of 180? Okay, so set it up and don't do it yet. I want to see, I want to make sure you guys do it right. Set it up first. 414 is what percent of 180? Okay, I wrote it down. Be careful of the words. I know you want to put the smaller number on top, but watch the words. Of is 180. Of goes here. Is refers to that number, and that is your 414. Or you can think of it, 414 is your part. Is always the part, and the of is always your whole. So yes, as you can tell, what's that?
I got the 414 and the X backwards.
Oh, okay. So then this is what you want to look for. You're looking for what percent. That's why the X is on top. That's your percent. Percent X. Okay, go ahead and finish it. See what you get. If you haven't done already. And it should be a number bigger than 100. Yeah, I'll start writing it, but keep doing it. Don't look at it. Okay, got the answer whenever you're ready, look. Okay. Done. Look, get 230%. 230%. Okay, that's that section. We're actually going to use this concept in the next section, which is our last section. Question before I do the next section or start the next section. Next section is all word problems, applications of percents, which is proportions. So we're going to look at, listen, fractions are everywhere. Everything's a fraction, right? Percent sale, percent of this is always percent. Everything percent, fractions, all part of life. So word problems, especially a lot of fractions and percents in word problems, and this is what we're going to do. So, okay. I can't believe I'm saying this is our last section. So 6.5 applications of percents. We're going to use everything we just learned and use it to word problems. Okay, so 1. The freshman class of 864 students is 32% of all students in the school. So the freshman class alone is 32% of all the students in the school. How many total students are in the school? So if we know 32% of freshmen is 864, we can find out how many total students are in the school by doing what we just did, proportion. It's just in a word problem sort of kind of fashion. I'll wait till you guys finish writing down. I'll still see if you're writing down. Guys, I don't know if you realize the words is and of are still here. Here's your of, here's your is, although that's percent, you got a percent. So part over whole. So if the freshman class is 864, then the whole class has to be more. The whole school has to be more, right? So this is your part. We don't know how many students in the whole class, right? That's what we're looking for in the whole school. So in a class school. We're looking for how many are in the whole school. So the freshmen had 864 and it made up 32% of the whole school. We want to know how many students are in the whole school. So part is 864. We're looking for the whole school. And it's just like we just did. Cross multiply. 32x is equal to plus multiply 86,400. And then we're going to divide both of them by 32. And whatever this answer is, it's going to be how many students are in the whole school. So 8,6,400 divided by 32. Okay. I can get 2 32s, which is 64. 2 and 2 left, bring down the 4. Okay, how many 32s and 224? 32 times 6. Let's say 12, 18, that's 192. That's close. Can we do 7? 14. Oh, perfect. 224. 7. 224, and that's 0 left, but we have 2 spots left, so we have 0, 0. So since it's a word problem, we finish it with words. Yeah, there are 2,700 students in the school. Questions? Two. Okay. A student, it's all about students. What is this? Okay, it's not yet. This is one last student. A student answered 86 problems on a test correctly. That's a long test. And received a 98% on the test. Ooh, that's a lot of questions. How many problems were on the test? Um, assuming all problems worth the same amount. So every problem is worth like 5 points or 4 points. Now this one, they give you directions because I bet you the decimal goes on. Round to, should be a decimal anywhere anyway. Here's whole number. But it's going to be a decimal in your answer. So you're going to round to your nearest whole number. Okay, so try setting it up. My interesting. My whiteboard. Sorry, I shut you out, didn't I? I'm sorry. Here, let me leave it up there. But my white. Oh, there it goes. There it goes. My whiteboard's frozen. I couldn't move it. Okay, a student answered 86 problems on a test correctly and received a 98% on the test. How many problems were on the test? Round to the nearest whole number. It couldn't be a decimal anyway because you can't have a decimal of a question. Okay, so 86 questions he or she got right. That means there had to be more than 86 problems on the test because he scored or she scored a 98. So that has to be your part. And we don't know how many total questions were on the test. And this person got a 98 out of 100. If you set up that way, you did perfect. Let's multiply 98x equals plus multiply 8600 divide by 98 divide by 98. Okay, so 8600 divided by 98. Okay, no, 98 to 86. I'm thinking it's probably 8 or 9. Let's do 8 first. 8 times 8 is 64, 72, 78. What's 9? 72, 81 plus 7 is 88. That's not 7, it's 8. 784.
They some big numbers.
Yeah, I know. They are. 7, 15, 7. I got 76. Bring down to 0. I do that right? I did that wrong. Hold on. 8600 divided by 98. I said 8, which was 784. 76 left. Okay, hold on. 5, 10, 6, 7, 15. Yeah, I got it right. Okay, I have a feeling I did it wrong. Okay, 760. So we need something left. So maybe 7. 686, 7. Okay, so now we get 686. We're going to subtract that. So make that a 5, make this a 10, that's 4, make this a 6. Remember, you said round, so we're going to have a decimal. 15, that is a 7, 74. All right, here's my decimal. We need one more place to round it up to a whole number. And bring the 0 down. 7, so that's also going to be 7. I don't even have to finish it because I know that's 686. So if I have my answer rounded, it's going to be 88 questions. Any question on that one? Next one I'm going to give to you guys to set it up and answer. See how you do. It's a small one, not big numbers. 3. A baseball player pitched and won 80% of his games. If he pitched 35 games, how many games did he win? Hey, while you're doing that, I need to look something up. So I'm gonna leave that there. You guys work. I'll come back to you in a minute. I gotta look something up. I'm quite sure how to look it up without doing it. I'm gonna need my phone. I do it with my phone. Okay. I don't want to move this on the screen. I can definitely look it from my phone. Something you look at on your homework just to check it. Or I do the next row. Okay. Hey, baseball player pitched and won 80% of his games. So 80 over 100, that's your percent. If he pitched 35 games, how many did he win? So The whole is 35 games, and we need to find how many he won. That should be your setup. Okay, so we're gonna cross multiply. And 80 times 35 is 20, I don't know. 80 times 35, I tried to do it in my head, didn't work. 0, 40, 0, 0, 8 times 3 is 24, 2,800. 2,800 equals 100x. I cross multiplying, divide by 100. Oh, this was a nice one too. The answer is 88, 28. So it's a word problem, so we finish the words. He won 28 of his 35 games. Yeah. He won it 28 of his 35 games. All right, so give me like 3 minutes. My phone wouldn't bring up your assignment, so I gotta do it on my computer. I gotta move the whiteboard. But just give me a few minutes and I'll be right, I'm in here.